Today we're going to discuss how to find the limits of a certain function. When you find limits algebraically, there are many different ways of doing them. One way is if you would have a function where you have x minus 2 and x plus 5, and let's just say we're all going to go over x minus 2, and actually instead of taking it to 1, we'll take it to 2. Now when we have this, we're looking at these values and we're plugging in this value. We're going to use what we know as direct substitution. Direct substitution is where we substitute the value of the limit into the function itself. When you plug in the function itself, what you realize is we have 0 over 0. Alright. Now, from there are many different ways of now solving this function. What we can do next is we identify, is there a common factor? Or one of our first methods is simplifying, or what known as dividing out. Alright. Now, with the dividing out technique, we simply are going to take out these two values, alright, and we get a remaining function, and we take the limit of that. This is known as expanding the function, alright, and eliminating the factors. So when we have this, we have left with x plus 5, which is a line, and we eliminated a whole. From there, we plug in do direct substitution, and I'm going to call this ds. And when we do that, now we find out our limit is 7. Well, there are other ways of finding limits. Another common way is when we're referring to one with rationalization. If you have a limit, let's just say x approaches 4, and we'll have the square root of x minus 2 over x minus 4. Once again, we're going to do direct substitution first. And what you notice, you have 0 over 0. Now, what that means is this is indeterminate form. And from this indeterminate form, we realize that we have a hole in our graph. Alright, through this we realize we have a hole. So what we're going to do is our second technique, which is normally called rationalization. The rationalization technique, what we're going to be doing is we're going to be taking our function and we're going to be trying to factor it out. But one of the ways we're going to factor this is by finding or using, oops, that's not a 2, that's a 4, alright, is using the conjugate, alright, of our even root, our expression of our even root. So we're going to have the square root of x plus 2. And we can't just multiply that to the top, we're going to multiply that to the bottom, because we only can multiply an expression by 1. Now when we do this, we distribute the numerator, and what we have is x, and then we'll have minus 4 in the bottom. And now what always does happen, do not distribute the denominator, or wherever you plug it in. I'm running out of room here. But you realize that these, once again, cancel out. From there, we take the limit, as x approaches 4, of our expanded function, the square root of x plus 2. And what we have is 1 over 2 plus 2, which equals 1/4. So what we just did was, we found our limit by rationalizing, or using, sometimes also people call it the conjugate. That right there, conjugate, alright, of when you have 0 over 0 again. So our first method, we use dividing out. Our second method is rationalization. Each one of these, though, we are always starting with direct substitution to see if that works initially first. So that's how we can solve for limits algebraically.